Let's solve linear equations. Now these first steps are meant to make the problem shorter or easier as soon as possible. So anytime you can combine like terms on either side of the equal sign, do that. It makes fewer terms and makes the problem just a little bit easier to do. If you have parentheses and you do want to distribute, from there you want to get all your x terms on one side and all your constants on the other, which means you're going to end up with letters on one side and numbers on the other. It doesn't matter which side they go on. Letters can go on left or the right. Same for the numbers. Once again, if you have like terms at any time, combine them. And usually the last step is to divide. Not always, but usually. And the way that we're going to do all this, we're just going to think opposites. And then once you do the one side, the equal sign, do the other. So for this first example, 5x plus 3 equals 12, the whole goal is to get x by itself. So we have this 5x term, it's the only term that we have. So we're going to keep this on the left side. But the 3 and the 12 are constants. They need to be on the same side away from the 5x. So if we keep the 5x on the left side, that means 3 has to go to the right, which means we have to get rid of that plus 3 from the left. Since it is a plus 3, the opposite of that is minus 3. And, because that's opposite, and then once you do the one side, do the other. So immediately I subtract 3 from the right side also. Now those are going to cancel, leaving 5x. Then 12 minus 3 equals 9, because those were like terms on the same side. So I'm going to combine them. Now I'm getting closer to my goal of x equals, so all I need to do is to get rid of that 5. Now it is 5 times x. Since it is multiplication, I'm going to divide both sides by the number in front of the x, which is 5. These 5's cancel, and it leaves us an answer of 9/5. Keep it as a fraction. Let's come over here and do this next one. I have an x on the right side, which means, and that's the only x I have, so I'm going to keep the x over there, which means I need to get rid of that minus 10 or the negative 10. Opposite of negative 10 is a positive 10. So I'm just going to add 10 to both sides. Over here they cancel, leaving, on the right side they cancel, leaving negative x. On the left side we have 45 plus 10, which is 55. Now this negative x is actually the same thing as negative 1x. So you may want to write that in. So you'll know to get rid of the negative sign, or the negative 1, and that is negative 1 times x. It's not plus or minus, it's negative 1 times x. We're going to divide by the negative 1 because that's the number in front of the x. And we get x equals, and 55 divided by negative 1 is negative 55. So watch out. See, this minus 10 was being added or subtracted because of minus sign after it. So that's why I did addition. But this negative 1 is being multiplied to the x. That's why I did division. Now in this example, I want my x's on the same side. Notice they're on opposite sides. And also notice I only have one constant, that's 8. So I'm going to keep the 8 on the right side. Which means I need the x's on the left side. 7x is already over there. I need to move that 3x over, so I need to get rid of it from this side. I'm not getting rid of the 3. I'm moving the 3x, which means I'm going to do the opposite, which is subtract it. It's a plus 3x, so I'm doing minus 3x. And once you do one side, do the other. Those cancel, leaving an 8 on the right side, and 7x minus 3x is 4x. Now that it's multiplication, I'm going to use division, and we get x equals 2. Now this next example, notice I have 8 plus 5 on the right side. Anytime I already have like terms on the same side, go ahead and combine those. And what it does is it just makes the problem a little bit shorter. See that? So now I have this x term. I need the constants on the same side. I need to get rid of that minus 9, so I'm going to add 9. Bring down the 2x, because the 9's cancel. 13 plus 9 is 22. I got 2 times x, which means I'm going to divide. We end up with x equals 11. Now these last two are really important, so be aware. Notice how x's on opposite sides and constants on opposite sides, which, what that means is I'm going to move these terms to where I have x's on one side, numbers on the other. What I do, I always work with the x's first, and I always move the smallest x coefficient first, or the term with the smallest coefficient. So what I'm going to do is, I'm going to subtract that 3x, because it's less than 7x. I want you to do the one side, do the other. These 3x's will cancel, leaving the 8. Over here I have 7x minus 3x, which is 4x. Then that plus 12 is still there, so I'm going to bring it down. So now I have one x term and two constants. So I need to move that 12 over with the 8, so I'm going to subtract it because it's being added. And we get 4x equals 8 minus 12 is negative 4. Now that's 4 times x, which means I'm going to divide both sides by 4. And we're left with x equals negative 4 divided by 4 is negative 1. Going to use the same procedure over here. I have x's and opposites, constants on opposites. I need to move the x's to one side and the constants to the other. I'm going to do the smallest x first, get rid of it. That's a plus 2x, so I'm going to subtract 2x from both sides. It's gone over here, leaving a negative 9, not just a 9, but a negative 9. Now I'm left with 8, and then 5x minus 2x is a positive 3x. I have my x term on the right side, my only x term, which means I need to move the x to the left side. So I have to get rid of it from the right side. So that's a plus 8, so I'm going to subtract 8 from both sides. And I end up with 3x on the right side. Negative 9 minus 8 is negative 17. Now it's multiplication, so I'm going to use division. So I'm going to divide by 3. And we're left with negative 17 over 3, doesn't reduce, equals a plain old x. Now these last three examples are similar to the ones I just did, except we have more than one variable, but we're going to use the exact same rules. So when it says solve for y, that means I want to end up with y equals, period, nothing else. So this first example, to get y equals, I have to get rid of the 2x. Since that is a positive 2x, I'm going to subtract 2x. And once you do the one side, do the other. Those cancel out, leaving the y, which is what we wanted. These aren't like terms, so I'm going to keep it just as it is, 11 minus 2x. And that's all you're doing. So be aware, there won't be any terms to be combined together in problems like this. Now let's do the next one. 3x plus 4y equals 7. I have a y term that I need to isolate first, which means I have to get rid of that 3x first, because it doesn't have a y. To get rid of it, since it is a positive 3x, I'm going to subtract 3x from both sides. And we're left with 4y equals 7 minus 3x. Now, those weren't like terms. 7 minus 3x, 7 doesn't have an x, 3 did. So I couldn't combine them, so I just had to write them down as they are. Now to get the y by itself, that is 4 times y, I'm going to divide by 4. Now when I divide the right side, I'm going to do each side individually. It's highly recommended. So we're left with y equals 7 over 4 doesn't reduce, so I keep it as that. Negative 3 over 4 doesn't reduce, so I'll leave it as negative 3x over 4. And that's the answer. As soon as you get y by itself, you're done. We'll do this last example. This is probably one of the more difficult ones you may see, only because of the signs. So once again, we have a single y term that we need to isolate, which means we need to get rid of that negative 5x. What's the opposite of a negative 5x? It's positive 5x. So I'm going to add 5x to both sides, because what you do one side, do the other. Those will cancel, leaving negative 6y. These aren't like terms. Keep them as they are. 9 plus 5x. Now I have a negative 6 times y. Since that is multiplication, I'm going to divide by negative 6. Not just a 6, but a negative 6. And over here on the right side, I'm going to divide each one of those separately by negative 6. Don't have to, but it's really to your advantage if you do. Those cancel, leaving a y. 9 over negative 6. 9 over 6 reduces down to 3 over 2. I'm going to move the minus sign either to the front or to the top, either one. So 9 over negative 6 is the same as negative 3 over 2. And then I have plus divided by a negative, which is a negative. And 5x over 6 doesn't reduce, so I'll leave it like that. And that is the correct answer. Now, if you're someone that wants to be, exact, then you really need to rewrite it as negative 5x over 6 minus 3 halves. Or you can write it as y equals negative 5, 6x minus 3 halves. Either way is perfectly fine. And that's it.